Welcome everyone. So today we are going to solve a very nice indices problem. A lot of students could actually do this in two ways. Okay, one was directly doing it, another was using logs. I'm going to show you both the methods. You can decide which one works for you. Okay, so I'm going to show you the first method, which is quite easy without using logs. Okay, so here we have 4 raised to 3 raised x minus 6. Now we have that is equals to 64. Now if you remember clearly, or if you have a clear cut idea of roots, you can say that 64 is nothing but 4 cube. And once you reach this particular step, then entire sum literally can be solved orally, because since the bases are same, I can directly equate the indices. That is the basic law of exponents and indices. Okay, so here I can say 3x minus 6 equals to 3. Okay, so now obviously in order to find the value of x, we are going to take all the numbers on one side. So here, since there is a negative 6, I will add 6 on both sides. So here this and this becomes 0. I'm left with 3x equals to 3 plus 6 gets you 9, and x is now becoming what? Dividing both sides by 3. So value of x is just 3. Okay, now for those of you, you can cross verify this. So 4 raised to 3 into 3, right? Value of x is nothing but 3 minus 6. That gets you 4 raised to 9 minus 6. That gets you 4 cube. And 4 cube is nothing but 64. So I can say therefore value of x equals to, x equals to 3 is absolutely correct. Okay, so now for those who think that acha, sometimes it gets tricky, sometimes it's not necessary that every time we are getting this, like you can recollect that this is a cube of 4 or something like that. Then in that case what happens is, see, let me write this again. 4 is to 3x minus 6 equals to 64. And if this was not something which you could figure out, what you can do is you will apply log on both sides. 4 is to 3x minus 6 equals to log of 64. Okay, so now what happens is 3 raised to x minus 6 will come ahead, and you will get multiplied by log 4. Now why did I do that? Log of any number raised to an index is equal to index into log of that number. Always the index goes ahead. Okay, this is a rule of logarithm. So this is what log of 64. Okay, so now what happens in this case is we'll keep 3x minus 6 on one side, and we'll divide both sides by log of 64 upon log of 4. Okay, now here again we can write log of 64 as nothing but what? We can write 64 as nothing but 8 into 8, sorry, 8 into 8, right? So obviously we know that it is 8 into 8, and 4 and 8 are like what? Basically 8 is double of 4. So let's write this 8 as nothing but what? 4 into 2 into 4 into 2. So this gets you 4, and this 4 again. So into 4, and this 2 and 2 also gets you 4. So now from here also you can figure out that you can write this 64 is nothing but what? 4 into 4 into 4. Okay, now obviously you must be wondering that why did I even think of doing this? Okay, please remember both 64 is completely divisible by 4. Whenever you have something like this, it is much advisable to find factors. Okay, so now going ahead, we can say 3x minus 6 equals to log 64 can be written as log 4 cube upon log 4, right? Now according to the law of indices, this index will come ahead. So we'll write 3x minus 6 equals to 3 log 4 upon log 4. So now this is getting cancelled. So you are left with 3x minus 6 equals to 3. Adding 6 on both sides. So this 6 and this 6 cancels. 3x equals to 9. Therefore, value of x is nothing but just 3. See, both the ways your answer was absolutely correct. But in general, it is always preferable to avoid logs as much as possible, because that just gets you too many workings. Okay, And if you are especially working for an entrance or any competitive exams, time is the key. You cannot waste so much of time in one single sum. So if that is the case, then I would recommend you that you should always have a very clear understanding of perfect cubes, perfect squares, primes, cube roots, square roots. All of that is very, very important if you're in case you're attempting for any of the competitive exam. So that's it for today. I will see you in the next video.